All right, recording has started, and here we are. So we're here with Daniel. Daniel's going to be talking to us about the life and times of a data engineer. So that'll be a good conversation, and we'll have time for questions. We'll have some time for questions at the end. But Daniel, I'll let you go ahead and take it away.
Sure. Yeah, so who am I? I'm Daniel. I've been running around online for a while. I'm a data engineer. I run a blog, Confessions of a Data Guy. Probably doing that 7 or 8 years, quite a while. It's kind of where I got my start blogging. Been doing Substack for a while. Seems to be getting pretty popular. Maybe like a year and a half I've been doing that. Hit about 10,000 subscribers on that, so it's doing well. I've been YouTubing maybe for a year now, on Twitter, being mean to people, and then usually pretty active on LinkedIn, posting stuff. Yeah, for a day job, I'm a data engineer, senior data engineer at Rippleshot. So we in like the fintech space, we do fraud detection for banks. So if you think about swiping your credit card or debit card somewhere, we're kind of behind the scenes doing the fraud detection. If somebody steals your card or online, theft, stuff like that. It's kind of what we do. Outside of that, I'm just a big outdoors guy. I do a lot of hunting, fishing, hiking, camping, that kind of thing. Doing a lot of family stuff. So that's who I am. The agenda, I'll just kind of go through my background, non-traditional background, how I got into programming and data engineering. I'll just talk about the skills and things I did to climb the ladder, not having like a traditional computer science degree, and then like what my average day looks like and how I solve problems and lead and mentoring teams, and then maybe talk about some resources that I use, and then maybe some technology to pay attention to in the data space. Yeah, so my background is non-traditional. Like I mentioned, I went to school for agriculture. I'm in Iowa, so like I went to school for corn and beans, as weird as that is, tractors, things like that. Um, so no classical. I've never taken a software class in my life. But I just kind of got tired of it after college, did that for a while, and I kind of taught myself some PHP way back in the day, a little Perl, stuff like that in college. And then I just kind of got bored with that life and decided that I wanted to do tech. And so I just kind of like took the easiest route, and I taught myself SQL pretty much. And I was going for like the analyst role back when data warehousing was big and SQL Server was all the rage. That's kind of well, the road I went down. I think I got a one like a Microsoft certification in SQL and taught myself. And then I convinced somebody at some point at a bank to hire me on a data warehouse team, and that was kind of like my first tech job, I guess, if that makes sense, but totally self-taught. And then I spent a number of years doing basically like the classic data warehousing. This was like maybe circa 2010, something like that, when business intelligence. I don't know if you guys remember that when that was all the rage, things like that. And I kind of moved into after the data analyst thing, kind of like programming SQL. I got better, moved into like the business intelligence engineer role. Kind of did like SAP, a lot of reporting. I got into more data warehousing then. Just started to pick up programming then, learned Python, taught myself that. Really loved it. I think that's the time I started being active online, doing stuff with GitHub, teaching myself more, and then as data engineering role kind of got popular. I kind of saw that, and I started to enjoy the programming, DevOpsy type stuff, and kind of moved over towards those roles. And my most of my career has been at startups. I didn't really like I was in a bank for a while, like the big corporate setting, office, wearing slacks, and I just couldn't do it. So I just kind of gravitated towards startups, smaller companies. And that was helpful in the long run because obviously you get to work on a lot of different things at smaller companies. So yeah, I kind of have been going from startup to startup right now. I think there's about 12 people in the current startup. I've been there about 3 years, which is one of my longest tenures in tech. Usually I was kind of hopping from start to start every year and a half or so. Yeah, I would kind of say my advice to people who don't have a necessarily computer science degree like I did, I think it's a benefit personally. I've worked with a lot of smart people and a lot of people who don't have computer science degrees, and they're some of the best software builders. Are very creative. They can solve problems the way other people can't, maybe because they just had to teach themselves, and they don't maybe have any self-imposed things that they put on themselves. So yeah, I'm definitely a fan of people from the kind of like self-taught like myself. So kind of like skills. What did I do to climb the ladder? I get that question a lot, especially on LinkedIn. A lot of younger engineers reaching out, asking for mentorship, things like that. Constantly get that question all the time. What can I do to get better? How did you get to where you're at? And it's not very popular, but one of the things I always tell people is you gotta work harder than the average person most of the time if you want to, if you're trying to stand out or be promoted over someone else, right? Or just you look at somebody else, say how did they get there? Usually it's by hard work. Um, People can take that like in the wrong way, not in like a toxic way of like you don't want to work 12 hours for your employer. I would never say that. I think it's hard work. For myself, I just invested that time in myself, right? I did a good job at work, but I also, you know, put a lot of time into myself and my own skills. And so basically outside of work, growing myself, whether it's reading and learning other languages. So basically make time to invest in yourself and your own career. Don't just work really hard at your job. That's fine. But typically when the jobs we work, the breadth of what we do isn't that big, so it's going to be hard to really grow a lot if you're, for example, you work at some place that are just on snowflakes or just on Databricks. What you're working on is probably going to be fairly narrow. So being able to do stuff outside of work, learn other things, I think that's a great way to grow and put time into yourself. And a lot of things I tell people is just learn. You got to write more code, become a better programmer. Obviously, if you're in the data engineering space, um, if you want to move up to the higher levels, you're probably gonna have to learn more than SQL. Usually, it's kind of like SQL and Python are the baseline. Everybody's expected to know that and do that, and that's where you start. But I always tell people to kind of broaden their horizons, whether it's Rust or Go or anything else. Just kind of it makes you a better programmer if you're learning new things, and then also learn a lot about a little bit of things. So I think one thing people notice as they grow in their career, especially younger engineers, they get really focused on one technology. Maybe they get obsessed with Databricks or something, right? And that's all they think about or all they want to work on. But I think the farther people go up the ladder, the more they realize, that scope kind of your job and what you need to do, and the problems to solve kind of widens, which means it's important early on in your career to learn things like Docker and, learn your way around the command line, learn about servers, be able to log onto a server, move around on the command line, learn a little bit on the network stuff, right? You don't need to be a genius, learn about cloud, Azure, AWS, GCP, and all of those companies have, free credits and free accounts you can at least open and play around. Obviously, Spark's a big tool these days, big data, so I really tell people getting into data engineering or in the data space, yeah, you definitely need to not get so caught up in one thing. Kind of, you don't need to, overwhelm yourself by learning that you need to be an expert in everything by any means, but it'll definitely help you in your career and help you in data. So you kind of start to learn a little bit about everything. It helps you solve problems because you have kind of a wider toolkit to pull from, and you at least will understand what somebody's talking about, right? If you're talking to somebody on a platform team or some other engineer from another team, they talk about something that just gives you a little bit of knowledge to be able to talk about stuff better.
Really.
And also uh, learning to write better. Personally, that for me was like writing blogs, things like that. Um, Learning to communicate better with teams, people around you. A lot of people, especially early on in their career, they just think that coding is what, you're a junior engineer, you just like writing code or SQL, and you just think you need to do that all day long, and that's fine in the beginning. But again, the more you move up to senior levels, the more you work with other teams, you need to be able to work with people, talk with people, communicate things, whether it's by email, Slack, or one-on-ones, things like that. So definitely, a lot of people forget about working on the soft skills, which are like basically extremely important if you want to move to like senior staff level jobs. And be able to like provide that sort of business value where they're going to promote you. You got to be able to, there's lots of people that can write code. AI can write code for us now, right? Decently. So you need to be able to talk to people, work through problems. Being a self-starter is important, especially I think it's easier for people who are maybe self-taught like me. That is kind of how you had to learn. But that can be harder for people from a traditional background, not being told what to do, being able to figure problems out. And then also just always tell people to read a lot, whether it's blogs or books or whatever it is on your own time. Just make sure you're you're probably not learning something if you're not reading. So I always make sure it can vary obviously depending on how busy you are, but making sure you're consuming some sort of content, whether it's YouTube or blogs or anything that kind of keeps you up to date with what's going on, learning new things. Um, and then the last two, being ruthless with time management, that's something that gets extremely important, especially as you move up the ladder when you start working on projects and you're in charge of projects and you have a lot of pulls. Maybe you're mentoring people and you have to spend some of your day helping people solve problems, working on your own things that you're required to work on. And then, project planning, you've really got to be ruthless with your time management. Professionally and personally, to take care of yourself and take care of your work, to be able to do everything you need to do. You can't just kind of wing it. I don't think that's a good idea. I talk about later when I talk about what my day to day looks like, how I do that personally. Um, and then also just not being afraid to struggle. Always making sure if you're not struggling with something or, you can't figure something out on at least a weekly or monthly basis, it probably means you're not growing fast enough, or you're not challenging yourself enough, if you're not kind of getting stuck. Um, I always thought as a young engineer, the more I was in, if I've been doing it 10 years, well, that means I know everything. I won't struggle anymore. It's definitely not the case. Um, if I'm struggling, it means I'm learning something new, and it's a struggle, and that's good. Um, yep. Yeah. So what kind of my like an average day for me looks like at Ripple Shot is, I would say depend. I mean, it can change a little bit depending on where I'm at in the life cycle of projects, but I would say generally speaking, on average, it's 50% coding and then 50% like other non-coding exercises, whether that's project planning, things like that, research. And first, I do like all my coding in the morning. As soon as I get up, kids are up, awake, and I'm making breakfast, whatever. I might have some PRs in, opening and writing code before 7 a.m. That's kind of my time. Personally works for me. I'm fresh, ready to write code for whatever I'm working on. And then usually my afternoons, I like to focus on what I would call like the thinking stuff. So whether it's project planning, I may be, making Jira tickets for, project I'm working on, or maybe a design doc to do something, or maybe setting up meetings to talk with people about what they're working on. So that's kind of like my day at a high level. But yeah, I would say besides coding, it's just a lot of high level architecture research. Like I said, if we're doing new projects, I might be reading documentation, looking at new tools, maybe putting together POCs, things like that, or just planning work, right? Even Jira. Like if the project's ready to go, maybe I'm kind of going through the documents or stuff I've done in the past and creating tickets of work and assigning points to them and figuring out who's going to do what. And then a decent part of my day is, mentoring other people. So it's basically help what I like to think of just helping other people solve problems. If they've got a block, how can I help them, or what are they working on? Talk with them, and just basically helping other people answer questions, solve problems. And then being a voice for engineering with product and the C-suites, that's just people above me, right? The VP above me that I report to, just making sure that I, know what's going on, know what's important to the business and the product, if that makes sense, and making sure engineering has a voice in that, making sure, they want something done next week, but, we need to do it right. It's going to take a couple weeks, which again, that kind of leads back to what I talked about before. It's why it's so important as you grow in data engineering and data to be able to talk to other people and other, that aren't engineers, that aren't in maybe the technical group, right? Especially with data being so important to many businesses. A lot of times you can work with sales, marketing, product, right? All these people, maybe they have reports or they want data for things, or, it's just important to them as a business. So it really is super important that you can be a voice to those people, know how to communicate with people outside of engineering, just how to, help people understand things, which takes practice to be able to do that, whether in writing or verbally, to be able to explain things to them, explain why you need to do something in a certain way, or why a bug happened, right? Why something broke in production, explaining it to somebody in the business is important. Yeah, so that's pretty much my day at a high level. Yeah, so 50-50. And then on the personal side, I always encourage people to, and I myself, get out regularly. I don't just sit in front of a computer I'm not the type of person that can sit there for 6 hours or 8 hours and just not leave my computer. That's not how I work. usually by 9:30 in the morning, I've already been outside, had a walk around the block, things like that. Take a solid lunch break, eat, exercise, run, stuff like that. I think it's incredibly important to, especially for people in tech, you just tied in the computer all day. It can be sort of stressful, making sure that I get outside and do things, I have hobbies, being healthy, and that definitely drives up my productivity and helps me deliver better products in the end for sure if I'm happy and healthy and sleeping well. It is better for everyone, including me. Um, and when it comes to solving problems, I do get a lot of these questions from people. They email me, like, how do I just randomly send me messages? My Spark cluster's not working, or blah blah blah, whatever it is. Obviously, this comes up even from junior engineers, right? That they just want you to solve their problem. They get a specific thing they're focused on. A lot of times, when it comes to solving problems, I rarely just tell someone do X, Y, Z. I don't really think learning comes that way. They're not going to learn. No one's going to learn anything, and I would never learn anything if somebody always did something for me. But generally, how I solve problems is, I think, first and foremost, is keeping things simple. Don't chase shiny solutions. I think these days it's very easy just with the prevalence of SaaS products and vendors in the space. Anyone who's been around data and it's on LinkedIn or anything like that, right? You're just constantly, bombarded with blogs and marketing and white papers and this and that. And I think that's all good and fine. It's great, but I always try to tell people to, take it with a grain of salt. Remember the basics. Stick to the basics. Things like that. There's no silver bullets that's going to solve your problem. Just do what you can and kind of ignore all the fluff, the shiny things. Also doing a lot of POCs and MVPs before jumping into things. This can bite a lot of people, especially in the data space, when we talk about, somebody just wants to use Snowflake just because, or use Databricks just because, or whatever tool, right? Just because they think they need to. Maybe somebody higher up told them to do that. Something that catches a lot of people is not, testing things out, questioning everything. I think everybody be naturally skeptical, question everything. Make sure you have kind of followed through a little bit. Do lots of planning, sketching, designing. So one of the main things I tell younger engineers, and what I see them struggle with the most, is they always try to jump straight to coding or straight to solutions without. They don't really think first before coding, right? They kind of jump naturally, especially technical people. They just want to solve the problem immediately instead of stepping back, talking to people, reading things, you're going online, finding what other people do, and just getting lots of different perspectives before you actually try to make a decision, or before you try to start thinking you know what the solution is, or even especially writing code. Never do that stuff before you have actually thought about things a little bit. And then finally, probably one of the most difficult parts of the job in data, and for me, is something I've had to learn a lot about, is how to lead and mentor teams and other people. Is basically, I would say, human relationships. I think for anyone who's in tech, that can be kind of the thing, right? If you are into computers, you kind of like programming and data, it can sometimes seem like you'd rather spend more time with the computer than other people, right? Or else you would have been in sales or something. So that's definitely a struggle area for me as well, and for a lot of people I've noticed. But some of the best ways, I think, is just being kind and understanding to people. I have a lot of meetings with people one-on-ones. Mentoring people, again, like I talked about earlier, doesn't mean solving problems for it. It means helping them solve their problem, helping them think about it. Whether that's just talking with them and they end up solving the problems, they talk out loud to you, or maybe giving them other ideas, hinting at things. There's a lot of ways to go about upskilling other people, which is super important, because I've had to learn the hard way. You can feel like you just want to solve everything yourself. You just want to be that guy that solves things because you know the answer. And one of the hardest things to do is step back and let other people and other people have other ideas, and actually, let them fail, let them actually implement something that you don't agree with. I think it's good for people to learn lessons. It's good for us to be able to step back and let other people try things, fail. Because that's how they're going to grow. That's how they're going to get to your level or the next level, to help you out more on the next project, by letting them actually, take steps and learn themselves. So that's, a hard thing that I'm still learning recently. And yeah, probably one of the harder things people have to do. As far as resources, a lot of people ask me, what books do you read, things like that. I mean, I read a lot of stuff and watch a lot of YouTube, just like everybody else. But kind of the basics I've always, for the last 10 years, last forever, that I've always tell people these are the basics for data engineering. It's definitely the data warehouse toolkit that everybody knows, but rough people, it's imperative for people to kind of understand the basics of data and modeling, things like that. The Pragmatic Program is a great book just for people who write code and work with software engineers. Just helps you maybe take a step back and not take yourself or life so seriously when it comes to programming. It's kind of treat it like an art more than science. And then two other great books, Staff Engineer by Will Larson and Staff Engineer's Path by Tanya Rai. Those are both fairly newish books in the last 5 years maybe that have really affected how I've grown and lead other people and learn and work with a business. They're both great books, just about really getting you to think more about just the data and just the code, and kind of come up a level and really think at a high level about the business and working with other people and actually having solutions that people use and enjoy. And then two of the Substacks that I read quite a bit are High Growth Engineer and then the Pragmatic Engineer. Both of those are great Substack newsletters that are worth their weight in gold for sure. And then technology you should pay attention to. Data engineering would definitely be Databricks and Snowflake and LLMs. Those are the two big players in the space. AI is getting huge. And then if you're in the data engineering space, definitely pay attention to Rust because it seems like that's kind of the future as well. I think that's all there is for the presentation.
That was great. We have one question, and also to anyone who's not in the Slido link yet, we have 7 people here now in this meeting. That's great. Anyone who's not in the Slido, we have a Slido here that you can join, and I will make sure to resend that link right now to the chat. That way you have it. It got sent out earlier in the LinkedIn post. Let me make sure I grab onto that. The first question we have in the Slido is, what are the best programming languages to learn for data science?
I've worked in, I'd say the last 6 or 7 years, I've actually worked specifically with machine learning, with data science. So I've put a lot of machine learning things into pipelines into production. That's what I do every day now. My last job was actually mostly that, working with data science. I was embedded in the data science team. I would say it's got to be Python. 90% of the data scientists use Python. Sometimes it's a little bit of R. You can see that a little bit with the data scientists, but generally they're not make anybody mad. They're typically not the best programmers, right? That's why there's data engineers around. But yeah, Python is the language of choice for machine learning. It's just the way it is. And people talk about other up and coming languages and stuff, but it's 99% Python. It probably will be for the foreseeable future for sure. It's gotta be Python.
It's the jack of all trades and the master of none.
Pretty much.
Python is.
Yeah, it's a bane. I mean, anybody who's been doing data engineering a while knows that I guess it's frustrating. Python can be frustrating. It breaks, fairly easily. Dependencies, pip. It's just it is what it is, but it's also very versatile. It's great for R&D. It's fast. You can move fast, right? That's part of the reason it's using data science. You can move so quickly and build things so quickly. And especially in the data science context, when you're doing lots of R&D and moving quickly, it's imperative, right? If somebody's using Rust to do that, they would never get anything done for sure.
I have a quick question for you. What do you think Python is so brittle? What about PY environments and stuff like that?
Yeah, I think it's just my experience over the last decade or so. I mean, eventually it just breaks. I think it's, not being a statically typed language. It's just, especially with data scientists, a lot of code that data scientists put out is just not, they're just not, that's not what they care about. They don't care about practical software engineering, which they should have to, right? Technically. They're not, that's not what they're focused on there. they worry about, features and the next cool model and the next cool package. Or not thinking about, oh, I should unit test this, or I shouldn't write a function that's like 300 lines wrong because it might break, and you know what I mean. It's just not, and Python lets them do that. So I have honestly, every day to day, like 99% of stuff I do is Python. So it's not like I can bash it too hard, but it's the truth. I mean, you use anything long enough, you probably get a little grumpy with it. That's kind of probably where I'm at.
No, actually, no. Perl, I love.
That's how I cut my teeth back then. Yeah, I learned Perl way back.
But you know why I could love it? And I got into fights with people on this. I made my Perl readable because I used good programming techniques.
Mm-hmm. That's what it really comes down to. I mean,
exactly.
We can be mad at Python, but it's really about the develop. It's about the person's attitude, the developer. Like the process around the expectations. You can't blame Python if it's really about setting expectations of what good code looks like, what code should look like before it reaches production, right? That's more of a breakdown of process which I've seen a lot, right? Like some 5 data scientists all get together and just write this monstrosity thing, and it's sort of working, and so somebody says, oh, I really love that model, we gotta have it now, and so it gets out, right? And it's not really Python's fault. It's like a breakdown of hey, we should stop a moment here, maybe refactor some of this stuff, or what I mean, write some unit test here, there, put some CI/CD in, that kind of stuff.
You're right, but there's a trick to that. I learned this, and I learned this later on in my career. But basically, we had this messy code, and it worked well. What I did was, instead of refactoring globally and just rebuilding it, what I basically did was I just refactored internally. Didn't change APs around. In fact, it totally made a huge difference. The code looked a lot cleaner. So that's one thing you can do. What you can do is time on a project is both your friend and your enemy. So when you get something like that, always keep it in the back of your mind when you get a little bit of time, sneak in a little bit of refactoring. Even a little bit can help clean it up somewhat.
Mm-hmm.
Daniel, I think about things that you've written too on your blog when you talk about unit testing SQL code, especially in Databricks, Snowflake, Spark in general, Spark SQL code. When we're trying to unit test it, it's okay. I can't necessarily unit test the SQL code, but I could write a SQL function that's 3 lines long. I could write as just a really small block of SQL code and then test it. But then you get into, okay, how many tests do you want to actually write for this? And you have to walk that line of what's an appropriate amount of testing versus what's just testing hell. And how do you get up to 90% test coverage on your CI/CD when you have 80,000 functions that need a test?
Yeah,
well, here's another.
I've been destroyed, and I've got so much. You have no idea how much hate mail I've got about some of the stuff I've written about unit tests, especially around SQL, and telling people they write too much SQL, that maybe they should use a little bit more data frame APIs instead of SQL. And I mean, look, yeah, you can, I've got unit tests that currently are covering, Spark SQL thing. You can do it. I think a lot of the trick is business logic, right? That gets wrapped up over time. It kind of atrophies and gets bad habits. Like I get in a perfect world, yeah, you can use SQL all day long, you can unit test it, that's great. But we don't live in a perfect world. Things atrophy, you end up with 1,000 lines subquery, things with 15 subqueries, and that's just the reality. And yet I've gotten a lot of trouble for that, having that opinion, but I have an opinion for a reason. I've been burnt a lot.
I was addressing one thing recently where we had a code that had changed and shifted, like the business logic in the code had shifted over time. And then this was a brownfield migration project. So we, instead of going into the code, we're using the documentation for the code that was built first before the code was built. And then later to find out that the code shifted, but the documentation never did. And so it was actually 3 versions behind where the code was. So anything you built off of was wrong. So it's tough.
Yeah. And here's another idea. You don't have to test unit. You don't have to unit test every function.
Exactly.
Yeah. What you can do is you got one function that calls a few functions. You can just test the top one and just make sure you get all the inputs and outputs.
Yeah, I would say integration tests are underutilized in data engineering for sure. I think they're lifesavers. I think they're the best thing ever. Like integration tests and then just having a development environment I've been. It's amazing how many data teams don't have like a development environment where they can. Where you're right, like maybe you just can't like unit test all this stuff, whatever the reason is, right? But if you have an integration test, like you're talking about, that maybe covers half the pipeline, or it runs, like you say, like 10 of the functions, or even like just having a development environment where you can actually like, that's not production, right? Where it has like production like code and our data, you can at least go out there and test things, right? And I'm always amazed. I don't know why data engineering teams are so behind when it comes to that stuff. It just seems like it's a real life. We're always behind some of those things where, we should push more for integration tests, for good development environments, and it's just not the case a lot of places, at least a lot of heartache.
Yeah. But remember, you got time. Use that. That can be a weapon too.
We have another question here on the Slido. What advice do you have for people who are interested in transitioning from data science or analytics into data engineering?
Yeah, that's a good question. I mean, I kind of did that. I went from an analyst to business intelligence, like reporting. That's what I did, was make reports. And SSRS and what's SAP a long time ago. That was my job. Basically, how I did it was like a skill gap. It was basically teaching myself how to be a better programmer and picking up things like DevOps. That's how I made the transition. It was hard because I think in those, when you're in a data science or analyst role, you maybe don't get the opportunities at your current job to mess around with data pipelines, or maybe you don't get to write a bunch of code right at somebody else's job. So that's why I think it's important to invest time in yourself outside of work, and your skills. If that's what you want to do, then the only way you're going to learn that, and you can't take boot camps, things like that, but the more code you write, which is a lot of what data engineers do, the quicker you're going to gain those skills yourself. It's just, I found it's hard. I mean, certain jobs you can maybe grow that way, but you're gonna just have to find time yourself to. And there's lots of resources for resources out there, right? There's a lot of data engineering practice stuff. Databricks has a community edition. You can go get a free account and play around and write open notebooks and write as much Spark as you want yourself. I mean, I don't think people take advantage of that stuff as much as they should. So definitely just get your hands dirty. It's a struggle, but it's also a struggle is how you learn. So push yourself to learn programming, pick up Python, learn your way around how do I use a command line, what is a unit test, how do I write one, things like that are going to go a long way, especially if you can write some of that code yourself, and even better, like take a step forward, like put your learnings in like your personal GitHub profile, right? Everybody can get one of those for free. No matter how dirty it is, write a little code, teach yourself, put it in GitHub, then you'll have something to show someone that, hey, look, I can teach myself this, and I have done this, and look, that'll probably set you apart from 90% of the other applications for that same data engineering job, because you actually have a GitHub profile, and you've like shown them, not that you're like a really good programmer per se, right? Because when I've hired junior engineers and looked at it, I wasn't looking at their I wasn't like going through their code on GitHub saying like, oh, look at this crappy Python function, I'm gonna hire this guy, right? It was more like, oh, this person actually like taught themselves something, and they put it out here, and they have like the propensity to learn, right? They took a step and did this thing. So yeah, I'm interested in that person.
More often than not, it's you taking that extra step. We're not talking about a big tech role, right, where we need you to be a principal level already. Most of the jobs, I mean, we're 97% maybe of all the roles that we are talking about right now are just show me you've tried, show me you've been around, maybe I need some experience, 3 years of experience in related things, and then that you haven't stopped, right? That you haven't hit that 2 to 3 year mark, and then you said, okay, I'm just gonna coast now, like until I retire. Like that you're someone that wants to keep learning is very important.
For sure.
Feel free to send more questions over there to the Slido. We have a couple more minutes here with Daniel. We did extend the time that we'd initially had, so we're good to not get cut off from the meeting in case that were to happen. One of the things that I wanted to draw back to on the slides that you were showing is that when you talk about actually, if you could pull them back up, I wanted to go to the skills slide.
Sure.
I know that prompted a question for me, and I forgot to write it down in the Slido, so that was very irresponsible of me. Here we go. Okay. So when we talk about writing and communicating, right?
Mhm.
That this, I think, for a lot of engineers is a thing that we don't pay attention to enough, right? We don't pay attention to how well do we write, how well do we communicate, uh, how do we practice that, right? How do we get better at writing and communicating?
For sure. I think it's easy. I see, especially with like junior engineers, it's fairly easy because they can just start with like doing better PRs, like just communicating their thoughts better. Because a lot of times they will just do whatever they want to do. Their PRs, they don't put any description in them. They just kind of like assume everything. They don't talk to anybody about what they're doing, right? So like, there's usually stuff you can do like right away to do better, whether that's like writing better documentation the next time you make a code change, adding more descriptions, things like that to your PRs. There's nothing worse than somebody opening up making a code change and maybe they put a title in, but they don't really like. That's it. It's just a big blob of code. They don't take any time to like summarize stuff, right? Or just talking to someone on Slack, right, about maybe you have an idea of how I want to solve this problem or something like that. I'm not sure if I should go down this road, just learning to um, do that, ask other people, reach out. And then also I'd say like speaking up. A lot of times people, I don't know if it's imposter syndrome or whatever, I get it can be like, especially if they're newer in the company or they just feel like they're more of a junior engineer, everybody else is above them, like not speaking up in meetings with people when you have an idea or they have a way something might be solved. Getting over that fear and being willing to like, speak up and tell people your opinion and why. So basically just talking with other people, not hiding, for sure. Those are easy. Anybody can do that, and has a chance to do that if you're on a data team.
I appreciate that. Yeah, I appreciate the emailing, the Slack, the calls, and then if a meeting could be an email, that would be great. That maybe will also help you save people time. They'll want to talk to you more, and you get to practice your writing. It's like a three birds with one stone.
For sure. And
I
I think more people should blog, honestly, right? Or even if it's on GitHub. I mean, I don't think enough people do that. It's a great way to, it's free to go on Substack and start your own newsletter, right? Just learning to write your ideas down, things like that, for sure. Whether it's on GitHub or Substack, or on LinkedIn, right? If you learn something, it's a great networking place, and you're wanting to grow in your career, go to another, that's a great place to start. You learn something like we talked about, talk about it, like summarize it, post it online.
and without the fear that it has to be perfect, right?
Mhm.
That's another thing I think we might get in our own ways is that I can't say this or I can't put it out there because I might be wrong about something. It's like letting go of that fear that maybe something you're saying could be 1% off from maybe what a best practice is. I notice for a lot of times for myself too. I'm like, I don't even know if this is the best practice. Should I say it? Like, say it, and then if it's not the best practice, maybe someone will probably call you out
Oh
because
yeah, it's the internet. Yeah,
people love correcting other people.
I've been doing it. I mean, I've been doing this a long time, writing online, and I still get people that tell me I'm an idiot. They'll email me or comment, like you're wrong, you're not. Like that's fine, I'm learning. It's just proof that I have to learn and grow. We're all the same. We breathe the same air. Nobody's a genius. You gotta be okay with that, right? You're not gonna learn if you don't stumble a little bit.
It's like the dichotomy of being a teacher and a mentor, and then other people telling you that you're wrong, and it's like, well, then you do it. Like, we have another question here in the Slido. How do you find junior or entry level roles in the data engineering space? It seems like a lot of job postings are more for senior and experienced roles.
Yeah, I can actually speak to this directly. So about a year and a half ago, I had maybe 2 years ago now, I'd done like a data engineering practice re-exercise thing on GitHub. It got really popular, 1,000 stars. A lot of people did it, and I actually had someone reach out that had done it. He's now a data engineer working for me, working with me on my team. He was not working in tech. He had just been teaching himself for a long time. He had done my exercises and stuff and had been following me and reached out to me saying like, "Oh, here I did these. Um, let me know. I'm growing. Let me know if you have anything sometime. And I work with him every day. He hired him. We hired him on as a junior data engineer, and he got promoted this year to data engineering. He's been doing about a year and a half, self-taught. And so I would say, work hard and go look for people, and you'll probably get like 1,000 no's, but you'll eventually. It's like a law of averages. If you don't give up, you'll ask people. Go find people at some company that you want to work for, somebody you've been following online, and be nice about it for sure. I still don't expect somebody to hand you a job, but it happens because I work with somebody that literally did just what you're asking. So it's possible. It's not going to be easy, but again, if you do the stuff we talked about to set yourself apart, she did. Learn stuff by himself off time, put it on GitHub, and it was terrible stuff, right? But it was obviously this guy was super hungry and learning, and there's gonna be somebody out there looking for that, right? They'll see that and be like, oh yeah, I want to grow. Yes, come work for me. I'll help you grow. You'll find it. So yeah, don't be afraid if there's no jobs online or you can't scroll through LinkedIn. You can do that and apply. But you can also just reach out to people, a couple people a week, say, hey, look, I'm working, I'm learning.
Yeah.
Let me know if anything opens up, and they'll remember you probably eventually.
It's a matter of time, right? Time and energy, and you're not giving up to the thing that you're working on. A lot of times, it was about a year ago, I also started looking for data engineering coming from data science. And I said, okay, I'm going to look for junior data engineer roles. And the point I wanted to call out here was, what do you have? Where are you coming from? Like, if you're going to data engineering, you're probably coming from a similar field where you have some skills that could be useful in the data engineering world. If it's not specifically the title that you ever had of data engineering before, you've worked in Python. If you're coming from data science, you probably worked in Python. You've used some SQL before. You've used R. I mean, we don't really use R, but you've programmed, right? And so at the end of the day, if you've got the programming skills, or you're really great at communicating and you're kind of not the best programmer, but you're really good at like taking problems and turning them into a more succinct, essentially business problem that you can help then translate into a data problem, and then you pick up your programming from there, right? There's some transferable skill that you probably have, so you might not need to look for junior or entry level roles, right? You don't have to sell yourself short on that, but you could also, right, if one comes up, you could apply for it, and you could just say, hey, I'm learning these things. I think this is a good role for me, but I wouldn't bottleneck yourself either, right, to just a junior or entry level role.
Yeah, definitely some reach for sure. I mean, typically, think about, I put job postings together, like, you're just somebody sitting there trying to come up with all this, they're trying, I want somebody to know Spark and SQL, but, they're, in the end of the day, they're looking for the right fit. They're looking for somebody who wants to learn, will fit into the team, right? That's typically, like, usually 80% of the decision in my experience is, like, they're looking for a good person to work with, not necessarily that they know everything. Skills can be taught typically, right?
And especially at bigger companies, when a hiring manager has to give a description of the role, HR puts the role into their standard template of what a job posting is supposed to look like, and then they have to include, like for job bands, they'll have to include years of experience and all these other random corporate things that you have to deal with that a hiring manager oftentimes doesn't care about half the bullets that are on there at the end when it finally gets posted. They're looking for a few core things. So I think that's a lot of times why people say you don't have to hit every bullet, because usually the hiring manager or the project they want to bring you onto isn't using all of the bullets anyway. They're just using a few of them. The trick is knowing probably which few they're using. But
Yeah, I've been doing this for a decade. And when I see stuff posted on LinkedIn, I'm like, technically I don't even I don't meet the criteria for this,
right.
It's like, don't worry about it.
And I like to support what you were saying about reading too. I this year upped my arsenal of books that are data related by probably about 6,000%, going from 1 to 60, and, and it's been amazing. It really, like, the reading and just picking things up by reading a book and then going out and trying it. Like, if you can then go kind of put it on and try it on GitHub, like Daniel's saying, is really useful. Usually the reading isn't where your knowledge or where your learning ends. The reading for me is where the learning begins, right? And then it's let's go test it out.
Yeah, for sure.
Now this has been fantastic. Any other questions? And if not, I'm sure Daniel would love to answer your questions or field any questions that you have. He also has a wonderful section that you can go to on Substack and on his website, where he would love to write more and you read the stuff that Daniel's putting out there. So those links again for your website and your Substack, what are they?
Yeah, the website is www.confessionsofadataguy.com, and then the Substack is Data Engineering Central. You can find me on LinkedIn too. I try to respond to everybody that reaches out to me, no matter what they're asking. I always try to give them a little bit of my time, give them a lift up, help, advice. So yeah, I'm fine with people reaching out there too.
I've bothered Daniel a few times on LinkedIn, so he's serious about that. I bothered him with this, he responded, so he's happy to help. Any other final questions here before we go? I do appreciate everyone else that joined while Daniel was talking, and this has been a recorded session. So we will put the session up on, Daniel, if it's fine with you, we'll put it on the YouTube that we've been putting kind of like the labs and the classes on. So they're all in one spot, and then I'll send you this recording as well, so that way you have it after for yourself too. Probably be a drive link, because it'll probably be 15 gigabytes. So I don't know if I can just email it to you, but it'll be a link that you have access to, you can download. Yes, this has been very. Oh, and if anyone needs the slides, could we message you later for slides if anyone asks? Or
yeah, for sure. I could send them your way.
All right, great. Yeah, we'll have the slides up too. If you need them, just message me, and then I can make sure we get those slides so you have them available too. There was a lot of nuggets of wisdom in them that I think would be very helpful for anyone that was here or watching the recording later on. Final questions? No. Amazing. Daniel. Here we go. Not a question. Oh, we have one in the Zoom chat. Not a question. Just a shout out. Big fan of your works, from your book to your articles. Also, Team Rust.
Yeah, Rust all the way. Rust or die.
Daniel, appreciate your time. Thank you so much again, and we'll be in touch.
Sounds good. Thanks. See ya.
Have a great night, everyone.
Bye.
Hey, Sam.